Question 1, part A, it mentions power, it mentions force, and it's asking for speed. Now I don't want you underlining things in the book, but if it's an exam paper, that actually could be quite a good idea to pick out the key words and underline them on your paper. So, power, force and speed are all mentioned. Now hopefully you can cope with the fact that power means work done divided by time, and work means force times distance, so it's force times distance over time, which could be written as force times distance over time, which could be written as force times velocity. And that sort of chain of ideas, that's what physics is all about. But if it's an exam, you don't really care whether you're using good ideas, all you care about is you getting the answers right or not. So the other way to cope in an exam, you know you've got to deal with force and power and velocity. You desperately look at the data sheet, see if there's anything that's vaguely useful to you. And we see here on the data sheet it says power is work divided by time, or power is force times velocity. Second part of the question, we worked out this top speed, the maximum range. If the battery lasts for 90 minutes at maximum power output without being recharged. So I'm looking at that thinking, is there anything complicated about that? And I don't think there is. It's straightforward. You've worked out what the speed is when the power's 12 kilowatts, and you're told that it carries on being that speed for 90 minutes. So finding the distance it can go is really straightforward. Part B is a discuss question. The discuss questions are the ones that really sort out the good candidates who are going to get top grades from everybody else. Now, a lot of people sort of think that discuss just means waffle, but in this question it does give you numbers. So when you're discussing, use the numbers to sort of try and tell the story. So one of the things it tells you how far the driver drives in a year. So if you know how far it drives in a year, it might be worth working out how much fuel they use. It also tells you how much carbon is emitted for every kilometre that you travel, so you could work out how much carbon is emitted in a year by the average driver. You do that first of all for a petrol car, and then for a hybrid car it's going to use less petrol, and you can work out from these two numbers how much less petrol it will use, what the ratio is. So if you work out how much carbon is emitted by the hybrid car, then you can work out how much carbon you'd save by using the hybrid car. And then as a final thing, because that will just be a number, and if you just get a number for how much carbon you save, it's actually not all that easy to know whether that's a good thing or a bad thing, whether it's a lot or whether it's a bit. But because it tells you here how much carbon is emitted by the average UK household, that gives you an idea of how big a saving it is. So perhaps you could work out how much carbon you save and then put that as a percentage of what the average household uses in a year. Question 2, you've got a mass hanging from a string that goes over a pulley, and it's pulling a trolley. So when the trolley is released, the mass is able to fall and pull the trolley. So the first part says state the energy changes of the falling mass. So state means you don't need to explain, you just need to say what they are. So the mass starts at the top, it moves down to the bottom. What sort of energy is it losing? What sort of energy is it gaining? Second part is for the whole system. So that's the mass and the trolley together. So you have to think about things like, are things moving at constant speed or are they changing speed? Do the mass and the trolley have the same speed or do they have different speeds? And sort of use those sort of ideas to describe the changes that occur. Part B, state what measurements would need to be made to investigate the conservation of energy. So if you're trying to find out is energy conserved or isn't it, what things do you need to measure? So you need to find out, you need to think about potential energy and kinetic energy, perhaps write down the equations for those two things, and then by looking at those equations, what values would you need to measure to go into those equations so that you could find out whether energy was conserved or not. And then the last bit, describe how measurements in part B would be used to investigate the conservation of energy. So for that I think you'd need to mention things like, presumably you've spotted that you need to measure speed in part B. Well, how would you measure the speed? What would you use? And once you measure the speed, how would you use the measurement that you got? Question 3, a small hydroelectric power station uses water which falls 4.8 metres. So calculate the change in potential energy for 1 kilogram mass of water falling that height. I'm not going to tell you the formula. You look it up, it's in your notes, it's in the book. It'll be on, might even be on the data sheet, have a look. Yep, it's even on the data sheet. So the formula for potential energy is there. So work out how much potential energy changes for 1 kilogram of water when it falls that distance. Part B, calculate the maximum power available from the water passing through this power station when water flows through it at a rate of that many kilograms per hour. So of course power is the energy per second. It tells you the amount of water per hour, so maybe you need to convert it to the amount of water per second. And you know how many kilograms there are per second, but you want to know how much energy there is per second. And this comes back to the thing we talked about quite a lot about if you really know what the word per means. You've already worked out the energy per kilogram. You can work out the kilograms per second. And what you do with energy per kilogram and kilogram per second to get energy per second. It's one of those situations where just thinking about the words saves you from learning equations. So if you've worked out already energy per kilogram and you've worked out already kilograms per second, think what would happen if you multiply those two things together. Energy times kilograms divided by kilograms times seconds. And you get energy per second. So there's lots of situations in physics where you don't need to learn equations, you just need to have a bit of common sense and to think and not panic and let the words tell you what the meaning is. Right, part C, state 2 factors that affect the usefulness of hydroelectric power stations for electricity production. I'll leave you to think about that one. There's no fixed correct answer, there's all sorts of things that you could suggest. And if you can relate some of these things to some of the calculations you've already done, might lead you to some sensible suggestions. So question 4 has got a graph of velocity against time, and the first part of the question asks you to describe how the resultant force on the car varies. Now I don't know any direct connection between force and velocity, but I do know a very important connection between force and acceleration, particularly when it's resultant force. You know, resultant force is mass times acceleration. So that's a very important idea. But how am I going to find acceleration? Well, it gives me a graph of velocity against time. So hopefully you remember. If you don't remember, you're going to go and look it up because I'm not going to tell you how you find acceleration from a graph of velocity against time. And when you've found that out, or you've reminded yourself, you can think about this graph here. When is the acceleration big? What happens to the acceleration as time goes by? And if you know what happens to the acceleration, and resultant force is given by the acceleration multiplied by mass, you should be able to explain in words what happens to the resultant force during those 10 seconds. Part B, calculate the maximum kinetic energy of the car. Tells you the mass of the car at the top. You need to know the formula to find kinetic energy. If you don't know it, is it on the data sheet? Remember, the data sheet won't be any help to you in the exam if you haven't got a pretty good idea already of what equations are on there and what equations aren't. Yep, there's an equation there for kinetic energy. So use it, put the numbers in. It says maximum kinetic energy. So of course that must be at the maximum speed, so you find the maximum speed. Part C, sometime later the car is travelling at a steady speed of 30 metres per second. The useful power developed by the engine is 20 kilowatts. Calculate the driving force. Now question 1 on this same exercise involved that equation. If you've just jumped into the middle of the video without watching that, then perhaps again you need to think, we're talking about power, we're talking force, we're talking speed. Let's look on the data sheet. Is an equation that's got power and force and speed, and there is. So if you use that equation, you should find what you're looking for.